Hey guys, welcome back to another portable power station testing video. This power station was sent to me by DaranEner. It's a NEO2000 and it's a lithium iron phosphate portable power station that you can charge using AC mains or solar. Just like my other videos, it makes no difference that this was sent to me by the company. You can expect a fair and honest review. If I see anything I don't like, you're going to know about it. And if something performs better than expected, you're also going to hear about that. Let's get started. As you can see, just like previous power stations that I've tested that are larger in size, you have two handles, making it very easy to carry when holding it in front of your body, just like a cooler. There is a nice handle grip under here, making it very comfortable to hold, as you can see in this image here. And on top, there's also a wireless charging area, so you can place your smartphone or other devices here to charge while you're using the power station. This portable power station weighs 56.5 pounds or 25.7 kilograms. The dimensions are 18 3/4 inches left to right, 10.5 inches front to back, and 13.5 inches bottom to top. Also included with this power station is this AC cord, same type you would see used with a computer. And the nice thing is you don't have a charging brick to carry around in addition to the power station. Also included is this XT60 going to MC4 solar panel connection cable. And the other cable included is this USB Type-C. As for the documentation, included is this "Thank you for choosing DaranEner products." And you have the warranty card right here. On the back it explains how you can get additional warranty time instead of the 2-year. You can also have it extended 3 more years to make it 5 years by registering online. And last is the user manual. Looking at the front of this power station, you can see there are 3 AC outlets. Each one has these rubberized protective covers, flexible plastic, and it's got good thickness. And you pull down on it to access the receptacles. All 3 are the same. The only thing I don't like that I see already is this connection here should have been a little bit longer into the unit so it's not pulling. When I pull down on this, it's really pulling at this area here. And I think over time, there's a good chance this is going to break off. And then you're going to have to keep this piece around to put over it by hand, or you're just going to say, I don't need this, and not use it. Now, I'm also looking at the attachment point and saying, why didn't they do it from the top? Because if you do it from the top, you'll have some protection if it does start to rain. This is not waterproof like many other ones, but you do want to get it out of the rain as soon as possible and wipe it off. But if this is coming from the top, at least the rain will have a harder time getting in there before you can pull the unit away to a dry spot. You always want to leave these in a dry area that's in a shaded area. You do not want to have the sun beating down on the unit, because if it beats down on the unit, it's going to make it even hotter, because there's a lot of heating taking place inside with the battery pack as the unit is in operation. Always place the power station in a cool area and away from rain. So this, if they put it on the top, would have been good, but when you're standing up and you lift this, it's going to be hard to see the plug. So I guess that's why they decided to do it from the bottom. The problem from the bottom is when you put the power cord in, it's going to be always against that flap. And I think over time, because this is kind of tight right here, this may crack and break. So I wish they would have made that just a little bit longer so this piece had a little bit less strain on that area. Now, the ideal spot would have been to have it open this way, from the right to the left. And by doing that, it would be easy, top or bottom, getting to that plug. So if this is up on a shelf and you want to get to the plug, you have to pull this down even further if you want to see it. But if you're standing up, it's fine at this location. But if it mounted from the side and opened like a book, then you could get to the plug, top or bottom, very easily. And you're also not going to have the power cord pulling down on this flap all the time as it comes out. So I would have liked to have seen them mount this cover just a little bit differently. The rest of it so far I like. Over here is your power button to turn it on and off. They have the same rubberized protection things here. You have your XT60, that's where you're going to connect your input for your solar panels. And I believe this unit you can do 600 watt input, which is pretty good. Over here is a reset button in the event that you have excessive current. You can reset it. AC charging is done right from here. Nice seals. Over here you have your DC jacks, 4 of them, and you have your 12 volt accessory socket. I believe it's 10 amps in total that you can pull from this section. Same thing here, it's just kind of tight. So the bottom ones here, when you go to plug them in, are going to keep this like that. But you never know, maybe over time this will soften up from flexing it all the time and not crack. Here you can see you have 4 USB Type A ports. They're Quick Charge 3.0. According to the manufacturer, if 2 devices are connected, it will be Quick Charge 3.0. If you have more than 2 connected, it's going to have 2.4 amps maximum per port. So we're going to try loading these up to make sure it can handle 2.4 amps for all of them. And over here you have your USB Type C, power delivery ports, 100 watts. More than likely it's going to be 100 watts for combined, not each. But we're going to take a look. When the portable power station was sent to me, the state of charge was below 10%, and which was surprising. Usually you get it 30 or 40%, but I got it at just under 10, I think it was. I had to charge it up, and I could tell you it did charge very quickly. It took about 1 hour and 3/4 to a little bit less than 2 hours to go from the 4% or 5% state of charge all the way up to 100. And here you can see the difference as it was charging up, as well as the charging input wattage. A short time later, you can see what it looked like with the percentage as well as the input power. The power station reached a full state of charge, 100%, just below 2 hours. And that matches up with the manufacturer's specification, around 1.8 hours. Over here you can see 5 blue bars. Each one represents 20% state of charge. So if this unit was down to 40%, you would only see 2 of these bars lit up. And down here it says 82.4 hours remaining before the battery goes dead. This power station has what's called a hibernation mode. So if there's no DC load detected on this unit for 3 minutes, it will go into hibernation. And if there's no AC output load after 8 hours, it will turn off. After turning on the AC output, I did wait about 8 hours, and sure enough, this did turn off. According to the manufacturer, when this is in hibernation mode, you're only going to be drawing around 7 watts from that battery pack. The lithium iron phosphate battery pack in this unit is 2073 watt hours. We're going to be testing that out when I do an AC output test. And according to the manufacturer, you can expect 3,500 cycles down to 80%. Maximum AC input for charging is 1,600 watts, and solar is 600. The wireless charger on top of this unit is rated 10 watts. And according to the manufacturer, there's overcurrent protection on this unit, as well as high and low temperature protection. To help preserve the battery life of this unit, when the state of charge drops down to 10%, the output for the AC receptacles is going to turn off. When they turn off, you'll still be able to use the DC outputs. Here's a look at the left side of the portable power station, and you have this cover that has openings to allow the air to flow in and out of the unit. The left and right sides both have this opening. Looking at the rear side of the unit, you have this very nice LED area light. Now, a lot of power stations lack an area light like you see here. Jackery has those small little spotlights, but this one happens to be very nice. Just push and hold, and you can see it gradually gets brighter. Push it once. Now it's dim. Push it again. Strobe effect. Then you have SOS. And just push it again to turn it off. And right here is a look at the other side. In case you're wondering what the bottom looks like, here it is. You got this rubberized plastic material, a big pad here, big pad there, and over here, let's zoom in closer so you can take a look at that label. Looking at this label of specifications, you can see this also has an uninterruptible power supply, and it's good up to 1600 watts. We'll be testing that out just to make sure the uninterruptible power supply works when it switches over. And you can see the maximum power output is 3000 watts for this unit. We'll check that out as well. 2000 watts is continuous. Let's turn the unit back on, push and hold. Turn on DC, you would push right here, push and hold. Over here it says DC and USB. Push once to turn it off. First, let's take a look at the wireless charging. I'm going to connect up my phone, let it sit on here for a while, just to make sure it's working good. So let's turn it back on, the DC output, push and hold. It's on. Take the Samsung Galaxy, place it on top, and we're going to take a look right over here to see what the wattage is. There we go. There we go. Charging is good. The manufacturer stated that 10 watts is the maximum for the wireless charging, so more than likely the DC circuitry in here is consuming power, which is adding to the 10. That gives us the 13 or 14 watts. Everything is charging just fine, and you can see not only do you have the DC and USB power indicators, over here it's showing wireless. Now over here, this moon, that's hibernation mode. To turn off that hibernation mode is very simple. You're going to push this fast, and then the one in the back for the light. And there it is, it's off. So it's no longer in hibernation mode. Let's take the phone off. Now that we know the wireless works fine, let's move on to USB Type A. I'm going to place a heavy load on those ports. Okay guys, there's no issues with these ports. I have it fully loaded up. 3.58 amps on this one, 2 on that one, and each one of these is roughly 2 amps. 51 watts, it was 52 a minute ago. Been running for about 20 minutes, so no issues with USB Type A. Let's move on to USB Type C, just below. After referring to the manual again, it appears that 100 watts is the total output. So what I'm going to do is I have a load tester that goes about 60. We'll put that on 1, and I'll place another load on the USB Type C output on this side, and we'll let it run for a while. Okay, you can see I have the USB-C set at 20 volt output on this port. Over here is a little module, and that's going to allow me to use the load tester right over here. So I'm going to set this for 3 amps, which is the maximum for that module. That should put us around 60, 61. And then I'll add something else in on this port, and then we'll let it sit for a while. Here we go. Okay, so that's showing 61. There is a voltage drop across these wires here, which makes it show a little bit lower wattage at the load tester, but I can assure you it's probably 59 or 60 that's coming off of this unit. Now let me connect something else right here. Very close to 70. I'm going to leave it like this for a while, about 30 minutes, just to make sure there's no issues, and more than likely it should be able to handle an additional 30 watts on this output of the 100. Okay, been running for about a half an hour. No issues at that 65 to 67 watt range. Now let me add all these loads back in on the Type A. Let it sit for another 20 minutes just to make sure it can handle all those loads together. Okay, no issues. Half an hour, 118 watts going. All these devices connected. Let's power it off and go on to the DC accessory socket test. You're going to see there's a line connecting all these together. That's indicating that all of these are going to be on the same output, a maximum of 10 amps. Now the manual says 8 is the maximum for this accessory socket, and then you could put the extra 2 here, or you could pull equally off of these, the 10. So what I'm going to do is I'm going to try putting 10 right on here on the accessory socket. If it can handle a 10 amp load for 30 minutes, you should not have any issues. 10 amp load is going to connect right now, and I'm going to let it sit for 30 minutes. Okay, 134 watts for about a half an hour. No issues at all. That section is good. Let's go on to the AC outlets. Let's turn on the AC output. Just push it and hold. Heard the click. And over here should say AC in a minute. There it is, AC. Right over here it says 60 Hertz 110. Now this system also allows you to change between 50 Hertz and 60 Hertz. We'll be testing that in a minute. First, let's take a look at the AC voltage output. 112 volts. Would have liked to have seen it a little higher in the 115 range. But as long as it holds that 112 throughout the discharge cycle when I perform the test, that will be just fine. Let's just make sure all these are the same. Yeah, it's roughly 112. Now let's take a look at the frequency, make sure it matches up. Let's switch this to here. 60.41. So it's a little higher than 60, which is really not a big deal, but if you have something that's a really sensitive electronic medical device, you probably wouldn't want to use it. You want to have a pretty stable frequency output of right around 60. So 60.4. Now let's try switching this to the 50 Hertz setting and checking this to make sure it changed. Now how you do that, you're going to push this button and hold it, and then you're going to take the button for the light and push it once. And you can see it's flashing 50 Hertz, and now it's switched over. Let's double check to see if it's now 50 Hertz. 50.56. So it does switch. The accuracy is not super high, but I don't think it's off enough to cause any issues. Now connected up to the digital storage oscilloscope, let's turn it on. Heard the fan come on, and it says AC. And you can see right over here, we do have a sine wave. And if we take a look here, looks pretty good. Now let's take this and switch it back to 60 Hertz, and then place a load on this waveform to see how it responds. A little bit of distortion over here. Let me see something. Yeah, there's a little bit of distortion here. It's still a sine wave, but I wouldn't call it a pure sine wave. There is some imperfection there. The 50 Hertz setting didn't show that, but the 60 is actually showing that. If you put it like that, you can't see it. But as you go further and further, you can see it's just a little deformed. So it's not pure sine wave, but it's definitely a sine wave. I'm going to be using a hair dryer like I normally use. And if you take a look here, when you have a plug like this, this is a problem. And that's why it's not good that they mounted this with the bottom, because this right here is not going to go in with this in the way. So I suggest they change the way it mounts. Come from the side only. Do not come from the top or the bottom. You connect this in over here. And here we go. Alright, so actually, under no load, there's a little deformation of that waveform. But as soon as the load comes on, it smooths right out. As soon as the load comes on, it smooths out. Alright, that's not bad. At least while the load is being used, you know you have a really good sine wave. So let's get this out of here and go on to the next test. Now I charged this up to 100% because I was going to be taking this outside to perform some load tests on the AC receptacles, but I remembered I wanted to take a look at the UPS function. According to the label on the bottom of this portable power station, you can use this unit as an uninterruptible power supply up to 1600 watts. The manual does not mention anywhere about the UPS feature, or how it's used. So I'm going to try and figure it out based on how it worked with other power stations. Right here you can see it's 100%. We're plugged into the AC outlet, and I have this oscilloscope running. It's plugged into the AC outlet. You notice over here, hopefully, the AC indication is flashing, and over here it says 0 hours remaining. So this is an indication that the power is coming off of this AC line and not the internal battery. That's also why it's flashing, to let you know that. So if I unplug this, or actually if I unplug this one, it should switch and say how many hours remaining, and the screen should not change on this oscilloscope. The same applies if you're using a computer. You do not want it turning off in the event of a power failure. So now this is no longer flashing. It's showing 57.4 hours using this 14-watt load. I didn't see anything change here. What we're going to do is plug this back in again. Heard it click, and now it's flashing again. Some power is going in, and now it's stopped. So it's going to keep this topped off while you're using the load. So now we didn't see any change because the wattage was so low. Let me connect up the hairdryer. I'm going to put it on the cool setting just to get a few hundred watts going, and I want to see how this reacts, and then I want to pull it and see if there's any change. So if I put that on and leave it on and pull this, it should switch over smoothly. So let's see. And it did. I heard just a slight change in the sound coming from the motor at the time that I pulled this cable out. So there was definitely some sort of a switchover that occurred. Now before I take this outside, is one thing I wanted to tell you is that this unit is designed to charge using only the AC mains and solar. And the reason why you can't charge it in your vehicle is because the input voltage range is between 33 and 60. So if you're charging this using solar, and you only have 12-volt panels, you're going to have to use two in series. I use a solar module, which happens to be around 48 or 50 volts, so it should be a perfect demonstration when I try it for this unit, but you do want to make sure that the voltage range is between 33 and 60. If you want to charge this in your vehicle, there is something that you can do. You can purchase a high-efficiency DC to DC converter, and you'll be able to take that lower voltage from your vehicle, 14 volts or so when the engine is running, and you'll be able to boost it up to 33 and charge this unit while you're driving. Now for the first test, what I'm going to do is overload the AC receptacles to make sure that there's protection. I'm going to connect the hairdryer and then add in the circular saw, and if that doesn't trigger it, I'm going to add something else in. I want to see how many watts before it turns off the output. Okay, here we go. Alright, so as you just saw, the two of these together was not doing too well. The saw was kind of vibrating. It wasn't going smoothly up to high speed. It looked like there was a soft start in place. Let me disconnect this and then try this again and see how it is with just the saw. There you go. It runs the saw. You can see when it goes to do the soft start, there's a little bit of like a shimmying sensation, and then it smooths right out. That's not exactly the greatest thing, but let's see. So it does work, I just don't like the way it soft starts. Let me put the saw on first, and then add the hairdryer. Alright, so it worked 2,360 watts, the saw and the hairdryer. I had to start the motor appliance first, and then I was able to add the resistive. Now I'm going to add something else, so we're going to have the saw going, add the hairdryer, and then a smaller circular saw. Let's give it a try. Alright, so this saw works fine with the hairdryer at 2,360 for the wattage. It could not power this along with everything else. It was just too much. The voltage was dropping, and I'm surprised it actually didn't turn off. It wanted to keep trying instead of turning off, and sometimes that's not good because you don't want to have a low voltage output to what you're using. You can actually damage the saw or whatever else you're using. So let me disconnect this circular saw, which is the smaller one. And then what I want to do is add a different load. Let me try a vacuum. Okay, so using this inductive load and that inductive load is too much for the unit to handle. Surprising, because the other power stations that are 2000 that I tested were actually able to do that. So let's turn this one on to see how it works. So there's no problem powering these, or even powering this with that or other devices. You just can't use two of these powerful motors together. I think the absolute maximum output is just a hair under 2,500 watts. Let's try it one more time. So this is at 71 watts. Okay, the power station's charged all the way back up to 100%. The soldering iron on one of the settings, the hair dryer on high heat, and that toaster oven is going to put us just a hair under, I think it's around 1,950 watts, that we're going to have continuously connected to the power station until this drops all the way down to 10%. Hopefully it's able to sustain that load. Let's give it a try. 1,973. 11. Okay, it just turned off a little below 10%. Manufacturer says it would turn off around 10%. So it ran no problem continuously with that just under 2,000 watt load. The manufacturer stated up to 2,000 watts continuously, so that's a pass. And the output voltage started a little under 112. I think it was 111.8. And the good thing is, throughout the discharge cycle, it ended up right at 111, so it hardly changed from when the battery was fully charged all the way down to when the battery was almost fully depleted. Some power stations, you'll notice at the end of the cycle, it starts to drop off down to 105, 103. You don't want to see that. So that's a good thing. That test passed. After the test, I immediately connected up the AC cord to charge it. I wanted to put a low state of charge on it, just so I could check the DC outlet. I want to put a 7 amp load on it and measure the voltage under load, just to see what it is when the battery is almost fully depleted. After that's done, I'm going to unplug this, take it to my solar panel to make sure we can charge this using solar. So let's put this on. 13.11, very good. So even at a low state of charge, you're going to have around 13.2 or 13.3 volts that you had when the battery was fully charged. Okay, you can see I have my two 400-watt solar modules. They're connected in parallel, so the voltage is going to be open circuit voltage, 48 volts, and peak power under load around 39 or 40. So it's going to be closer to 33, the lower end, than it is 60, the high end of the input voltage. I did verify the maximum power output that I'll be getting under the conditions today. The sky is pretty clear, but there is some haze. So I'm not going to get the full 800 out of these panels. I'm getting around 670. When the panels were connected to the NEO2000, the most I was getting is between 494 and 510 watts. So I think it must be because the input voltage is closer to the lower end of that input range than as opposed to the higher. I've seen it in the past, so if you change your panel configuration to get the voltage output to be closer to the 60 volts, more than likely you'll be able to get the 600 without any issue. Now that all the testing has been completed, we can quickly go over the pros and cons. On the pro side, the wireless charging works just fine. USB Type A and Type C, there are no issues. I like the fact that this unit does not have a large charging brick. You could just take the AC cord, plug it directly into the unit. Just like the manufacturer states, you can charge this just under 2 hours when the battery has been fully depleted. DC 10 amp output over here, no issues at all. The unit is very easy to carry with these handles in front of you. You have a nice LCD display, and on the rear side you have that very nice area light. When I did the 2000 watt maximum continuous power output test, which happened to pass, just like the manufacturer said it can do, I noticed that the AC output voltage was very stable throughout the discharge cycle, and that's exactly what you want to see. It was around 11.8 when the battery was fully charged, and at the end of the discharge cycle it was down to around 111 volts. Now the manufacturer says 3000 watt maximum output for this unit, and I'm not sure if they mean 3000 watt surge being the maximum output, or you can use up to 3000. If they mean 3000 watt surge, yes, I could probably go along with that. If they mean 3000 watt maximum power output, I'm going to have to disagree on that one, because the highest I was able to achieve was right around 2450 watts. Another pro on this unit is the frequency is switchable between 50 and 60 hertz. No delay in charging after a full discharge on the unit. Due to the good cooling system, the unit has an uninterruptible power supply, lithium iron phosphate battery, and the DC output voltage over here is very stable throughout the discharge cycle. The output DC voltage is roughly 13.25. Now the cons are, I do not like these covers. They should not be opening from the top. You can see how springy that is. That's going to want to snap. It's a problem for certain plugs like I showed you. So what you want to do is make these smaller. They shouldn't be as wide. Make them a little more narrow, and make sure they hinge on the left side, all of these. So you can open it this way and make sure there's enough room when they put the new tabs in here so they do not snap off. The frequency for this unit, I tested it using not just one but two digital multimeters, and I verified that it is a little off. That's nothing major, but if you have sensitive electronic devices, especially medical devices that are sensitive, you might not want to be using this power station. So it is 60.4, just a little above, and I think the 50 hertz setting was 50.28 in that range. During the testing, we discovered that you cannot use two high inrush motors at the same time. It does not want to do it. You can use one with no problem. I tried the shop vac. Even off camera, I tried some other power tools, grinders, sawzalls, refrigerator, and it all works fine. But if you try and use more than one, that voltage comes down with that soft start. Another con is that you cannot use this to charge in your vehicle unless you use a high efficiency DC to DC converter and adjust the output voltage of that DC converter to at least 33 volts. If you're going to be using solar panels, as you saw outside, you're going to want to end up keeping the voltage going into this unit from your solar panels on the high end of that 33 to 60 volt range. If you keep it at the lower end, you're not going to get the most output out of your solar panels like I showed you in this video. So for 60 volts, I would recommend using 3 12-volt solar panels in series, and then you could place those 3 in parallel with another group of 3 12-volt solar panels in series, so you can have 600 watts, and the voltage will be right around 60 volts going into this unit, and you should get the maximum output. The one thing I really wasn't happy with was the fact that I overloaded this and it wouldn't turn off. The only thing it did was decrease the power output. You heard the saw slow down. Everything was getting a lower level of voltage. That's not good, especially if you're not going to be close by when that happens. You can end up damaging some equipment due to low voltage. And guys, that is it. I hope you enjoyed this review. If you did, be sure to rate, thumbs up, and share. Thanks for watching.